Okay, in this screencast, we're going to be looking at the introduction to water systems, but we're going to be focusing on ocean currents and circulation. So you should be able to explain how temperature, salinity, and density can drive circulation of ocean currents, and then also how does that circulation impact climate in different parts of the world. Okay, so the essentially ocean currents are moving water all over the globe. So you can see we've got this huge conveyor belt of water moving. And we've got things that are warm ocean currents, and we have other things that are cold ocean currents. In general, the warmest waters you would find generally at the equator, right? And those are going to, if they originate there, are going to be warm currents because that's where the sun is hitting and shining. And cold water currents tend to move from the poles towards the equator. So in this direction. But there's other things that are driving those factors, and we'll take a look. So surface currents are moved by the wind. So, and the Earth rotation can increase those circular movements, right? And that's just the upper 400 meters. But we also have a lot of these deep water currents. And those deep water currents are driven by water density, and that has to do with salt and temperature. So they call it the thermohaline. So water density is going to depend on cold because cold water holds more salt than warm water, and it's more dense. So if it's more dense, it's going to sink. Whereas upwellings result if you get the warm water, it's less dense, it's starting to rise from the depths to replace it. And then you get these downwellings occur if you get the cold water rises and is replaced by warmer water above. So it's this like circle of upwellings and downwellings. And all of this movement of water is going to move heat, redistribute heat in different places. So here is a cold water current coming from, the Antarctica up. This is the Humboldt current up the coast here along Chile and past Peru. And you can see because it's coming from the south, it's a very cold water current. And so that's going to impact the climate here is probably going to be much cooler than if it were coming, than a current coming from the north, coming from, in this case, coming from the equator, but it's not. This is also another cold ocean current coming up the coast of South Africa as well. So that is going to be influencing the climate where it'll be cooler here than it would be if it were a warmer current. You should be able to give examples of cold ocean currents. And then here is a great example of a warm ocean current because we feel the effects of it, not as much as the British Isles and Spain, but the Gulf Stream that's coming up from the equator is a warm water current. And so Europe experiences much warmer climatic temperatures at the same latitude than does major parts of North America because this warm Gulf Stream water really helps to bring some heat up from the equator. There's also a nice warm water current coming down the coast of Angola. So that's bringing warmer temperatures here as well. So you should be able to talk about the fact that we have warm and cold water currents, and the cold water can hold more salt. It's more dense. It tends to sink, but it's still going to be moving from the northern and southern latitudes towards the equator. And the warm water currents are going to be moving heat, dispersing that more towards the poles.